In order to solve polynomial inequalities, we will have to find test intervals for the given polynomial. To determine the intervals on which the values of a polynomial are entirely negative or entirely positive, we use the following steps. First, we will find all real zeros of the polynomial and arrange those in increasing order. These zeros are known as the key numbers of the polynomial. Then we use those key numbers to determine its test intervals. Lastly, we will choose one representative x value in each test interval and evaluate it in the polynomial. When the value of a polynomial is negative, the polynomial has negative values for every x value in that interval. When the value of a polynomial is positive, the polynomial has positive values for every x value in the interval. So let's try one example right now together. We'll definitely do more next class. So just like a polynomial equation, we need to start by getting our inequality with 0 on one side. So I'm going to add 4 to both sides here. Now I have the polynomial 3x cubed minus x squared minus 12x plus 4 is greater than 0. So this is asking us, when is this polynomial greater than 0? Or when is that polynomial positive? So now we need to factor that polynomial so we can find its zeros. There are 4 terms, so I'm going to factor by grouping. My first GCF is x squared, that leaves 3x minus 1. My next GCF is negative 4, that leaves 3x minus 1. So now I have 3x minus 1, my binomial GCF, multiplied by x squared minus 4. Now remember, x squared minus 4 is a difference of squares, so we can factor that further to be x plus 2, x minus 2. So now here to the right, we're going to use the zero product property to find the key numbers of the polynomial. So we set each factor equal to 0 to find that. If 3x minus 1 equals 0, then x equals 1/3. If x plus 2 equals 0, then x equals negative 2. And if x minus 2 equals 0, then x equals positive 2. So those are our key numbers where we know our polynomial equals 0. So now, in order to visualize this, I like to create a number line. And I will place these 3 numbers in order on that number line. Negative 2, 1/3, and 2. Now remember, we know our polynomial at these values is 0. Okay? Now what we can do is choose an x value in each one of these intervals in order to check the sign of our polynomial in that interval. So for this first interval, I can let x equal negative 3. Now, you could have chose negative 4, negative 5, negative 6. It really doesn't matter as long as it's less than negative 2. Now, I'm going to plug negative 3 into this factor polynomial, one factor at a time, to see what happens. Now, if I plug in, so I'm going to have 3 factors. Now, if I plug in negative 3 into 3x minus 1, I get negative 9 minus 1, which is a negative. If I plug negative 3 into x plus 2, that gives me negative 3 plus 2, which is a negative. And then if I plug negative 3 into x minus 2, I get negative 3 minus 2, which is a negative. A negative times a negative times a negative means that this overall polynomial is negative in this interval. So now, in this interval, I will choose x equals 0. You can choose whatever number you like between -2 and 1/3. So once again, I'm plugging 0 into those three factors. If I plug 0 into the first factor, I get 0 minus 1, which is a negative. If I plug 0 into the second factor, I get 0 plus 2, which is a positive. If I plug 0 into the third factor, I get 0 minus 2, which is negative. A negative times a positive times a negative is a positive. So we know our polynomial is positive in that interval. Next, for this interval between 1/3 and 2, I'm going to let x equal 1. If I plug 1, okay, now we're going to plug those into our three factors. If I plug 1 into my first factor, I get 3 times 1 minus 1, which is a positive. If I plug 1 into my second factor, I get 1 plus 2, which is a positive. If I plug 1 into my third factor, I get 1 minus 2, which is a negative. A positive times a positive times a negative is a negative. So we know in this interval, our polynomial is negative. In our last interval, greater than 2, I'm going to let x equal 3. You can pick whatever number you like. We're going to plug 3 into our three factors. 3 times 3 minus 1 is 9 minus 1, which is a positive. 3 plus 2 is a positive. 3 minus 2 is a positive. A positive times a positive times a positive is a positive. So we know our polynomial is positive in that interval. So now we need to decide which intervals is our polynomial positive, because that's what the overall inequality was asking us. When is it greater than 0? So we know it's positive in these intervals here. So writing our answer in interval notation, well, let's do inequality let's do interval notation. We go from -2 to 1/3 with parentheses because we don't want it to be equal to 0, union with 2 to infinity. And if I graph that on a number line, -2, 1/3, 2, I will have parentheses here to show we want all x values in between there, and parentheses there all the way until infinity. So we have all x values where we tested on our interval where they came out positive because we were looking when the polynomial was greater than 0.